All right, so welcome everyone to our class meeting. Which just two of us, but that's okay. We'll still get going here and talk about some things. I'm going to talk first off about upcoming class meetings. Next Monday, we will not have a class meeting. I just canceled it. I just sent out the cancellation for next Monday. We will have a class meeting the following Monday. So we are fine in terms of on Monday, the 27th of February, we will not have a meeting because I will be, as I was telling Furman, my wife and I are leaving for Canmore, Canada tomorrow morning, and we will be there all week. We'll be coming back next Tuesday. So next Monday, no class meeting, but we do have a class meeting on the 6th of March. Okay, so your first actual assignment is not due until the 26th, so that's this week. But next 27th, no meeting for class, but we will have one on the 6th and continue on through our classes from there. So just a quick note about that. If you saw the cancellation come in, that was for next week's meeting, not today's meeting. The other items, again, I think my wife and I have lost our minds. We are going to Canada, and it's going to be -3 for a high on Wednesday with -12, and they're calling for 15 to 25 centimeters of snow. So say a prayer that we'll even get out of Calgary and make it out to Canmore. It's going to be a little bit interesting. Any questions about the schedule, about what we got going on? What's like I said, the only changes, we will not have class next Tuesday or next Monday. I'm taking personal days and actually taking a little bit of a vacation. Kind of testing out this retirement thing, seeing how it might work. So, all right. Any questions? Anything that's come up during the last week since we had our last full class meeting?
No question.
Okay. Everyone's still good about how you do your uploads and how you do the labs and those things? I think everyone's been able to get into NetLabs, so that's not a big deal there. So make sure you're able to get into netlabs.stanley.edu and make sure you're able to log in and do your labs. We left last time talking about OSPF and discussing what is called a designated router. Now we go back just a little bit real quickly and help you remember that when an OSPF router boots up, it establishes neighbor relationships by sending out hello packets. Now those neighbor relationships are sent, they're actually multicast, typically those hellos, are sent out to 225.0.0.5, which is all OSPF routers. Now that multicast address sometimes shows up on exams like chapter exams and even on things like a CCNA exam. So 224.0.0.5 is all OSPF routers. We're also going to learn another address, 224.0.0.6, which is all designated routers. So that would be your DRs and your BDRs. And we'll discuss that in a minute. But you'll notice that every single machine, every single router has to create a neighbor relationship with any other router running the OSPF process in its area. So the reason that becomes an issue is in a multi-access network. In other words, an Ethernet network really is what we deal with mainly. There are others, but mainly Ethernet networks. In those Ethernet networks, if we did not have some way to change this default behavior, if you had 20 routers, you would have to have 190 adjacencies to maintain all the adjacencies. So we've got this formula here, which is n times n-1 divided by 2 is the number of adjacencies. So as you put in more and more routers into a multi-access network, which by the way, really OSPF, we do typically use an Ethernet type core. But when we do that, we end up with large numbers of adjacencies. That is a problem. So they came up with what's called a designated router. So instead of flooding your LSAs out to everyone, and instead of sending it out to 224.0.0.5, there's an election process so that you get a router that is going to be your designated router. And so instead of flooding them all out to everyone on a multi-access network, what actually happens is those particular updates, you see all those floods there, with a DR, the LSAs go to the DR and BDR, and then the DR sends it out to everyone. So you'll notice it's kind of like if you remember back in the old days how we had domain controllers. Remember way back in the Windows days when you had a domain controller and backup domain controllers? it obviously is different in terms of what it's doing, but there's a similar process going on here. The DR, or designated router, acts as a central point for adjacencies. All the routers only form an adjacency with the DR and the BDR. They do a format with both of those. And then when an LSAs are broadcast, they go out to 224.0.0.6. They go up to the DR and BDR, and then the DR will send it out to 224.0.0.5. So it doesn't have to go out to everyone. So we're not ending up with this flooding of LSAs in a multi-access network. So here we're sending out 4 LSAs for everybody for R2. And R1 would have to do the same thing. R3 would do the same. R4 would do the same, and so on and so forth. And you'll notice that's a lot of traffic on the network in a multi-access network. So with this setup, with the DR, we establish our adjacency with our designated and backup designated router. The DR can then send out the LSAs. Much more efficient use of your bandwidth. The other thing you'll notice here too is that backup designated router, the reason for it being there is in case the DR goes down. And if, unless something has been changed drastically, these other routers will be what's called a druther, which means they're not a BDR, they're not a DR, but they could be a DR or BDR if the DR or BDR goes down. So in other words, if the DR goes down, the BDR becomes the DR, and one of the druthers is elected to become the backup designated router. All right, does that make sense? All right, so yeah, all right, so that's a simple look at OSPF. Let's go in and actually look at configuration. Now, one of the things I discussed with you last time is I did discuss with you OSPF router ID. Remember, it's either going to be something that you set under the OSPF process, or it's going to be the highest loopback address, or it's the highest IP address on any actual physical interface. Now, we're going to use this as our kind of our base topology, our reference topology. So you'll notice we're going to use this for our all of our discussions of OSPF. And we're only discussing area 0 because we don't discuss multi-area OSPF. All right, so router IDs. 32-bit value represented by IPv4 address. This is true, by the way, even if your devices are running all IPv6, you have to have a 32-bit router ID on the device. And it's used to help identify the router in the OSPF database descriptor packets and in the DR election. Okay. Typically, the router with the highest router ID is selected as your designated router, and the second highest is your backup designated router. That's important because you can control that election, and you want to be able to do that. But here's a little flow chart that tells you if the router ID is explicitly configured with the router ID command, that's your router ID. If not, it looks and says, is there any loopback IP addresses? If yes, the highest loopback address will be used as the router ID. And then if not, it's the highest active IPv4 address. What if there's none of these exist? There's no IP address at all on the device. Remember the example I showed you last week? What happens when I tried to start the OSPF process with no router ID available? It wouldn't start. It simply would not start. So if a router ID cannot be chosen by the router, it will not run OSPF. Okay. So here we have our loopbacks. So we've taken on R1 and put a loopback address of 1111, and that is the router ID. Now, if you then go in and put a router ID, manually put in a router ID, you have to understand you have to clear the OSPF process for that to get changed. So be aware that's something that happens. In fact, I'll see if Packet Tracer may not do this. And that's one of those things why I like using real equipment and Packet Tracer, because Packet Tracer doesn't always work exactly like a real router or like a real device. I wish it did, but it just doesn't. But let's see here. Let me go ahead and do this since this is my machine. Yeah, I'm gonna stop share since this is being recorded. Not that it wouldn't matter really, because it's not like my email address is not public knowledge. Has to be since I am a public employee. All right, so I'm inside of here. I'm gonna pull out a 4331. I'm gonna pull out a switch 2960. I'm just gonna throw a cable between here and there just to get us a gig 000, gig 01. Okay. So I'm gonna go in here, CLI, let it boot. All right. So config, boop. Ah, I hate when I do that. No IP domain lookup is your friend. Big T, no IP domain dash lookup. All right. Host R1, just for grins. All right, so we're gonna do interface loop 0. We're gonna do IP add 1.1.1.1 255.255.255.0. Okay. We'll do router OSPF 1, and then we'll do a do show IP prot, and you'll see that our router ID is 1111. Now I'm going to go in here and do a router dash ID of, let's just do 100, 100, 100, 100. Okay, this switched automatically. Typically, you have to clear your OSPF process. Typically, you have to do a command do clear IP OSPF process, and then just say yes. Typically, on a real router, you have to do that in order for it to take that new ID. It's shown here in Packet Tracer, it's taking that new ID immediately. And maybe in version 15 of the iOS, actually what I'll do is, since we're here, I'll just do a lab real quick for myself. And we'll let it boot while we're in the class. Oh, I was doing it wrong. I was thinking my other class. My CCNP class is using is actually using CML or Cisco Modeling Labs as for the class, and so got to show them that today. I'm gonna let this boot while we're discussing. So we'll come back to that and check on a real router and see if it does it. Okay. But here we can see configuring it explicitly using the router ID command. This is the way you really should do it because there's no way it can go down. There's no way it can be accidentally removed. And you also can control who becomes the DR and BDR. You'll notice here, if this was a multi-access network, router 3 would become the DR because it has 3333, and R2 would become the BDR because it is 2222. So typically we want our designated routers and backup designated routers to have the most horsepower in terms of CPU and memory, and also have the best bandwidth to those devices. So, all righty. Now, OSPF can exist in a point-to-point network. And if you do that, there is no BDR, there is no DR. So on a point-to-point network, there's no need to mess with the adjacency or neighbor relationships because there is literally one adjacency on a point-to-point network. So you can easily do that. The other thing that's a little different about OSPF is when you put in network statements, you use what is called a wildcard mask. Now I'm gonna let you in on a dirty little secret. All right. So let's look here. We know this is gig 000 on this right here. So I'm going to go into interface GI 000. All right, I'm gonna do a no shut just so it comes up. All right, so it's up and running. Put an IP address on it of 192.168.12.1, 255.255.255.0. Okay. Now, if I wanted to add this to OSPF, router OSPF 1, the correct way to do it is to use what's called an inverse mask or a wildcard mask, which is the same type of mask that we use in our access control list that we will discuss. But a wildcard mask is basically just take your current mask and subtract it from 255, 255, 255, 255, or everywhere there's a 1 in your mask, convert that to a 0. Everywhere there's a 0, convert it to a 1. So in my example here, in order to actually make a network statement for this network, I should put in network 192.168.12.0 space 000.255 area 0. And that will place that into area 0. Now, if I do a do show IP protocol, you will see that I am routing for that particular network in area 0. But let me show you a dirty little secret that is actually true and is a little bit funny, but it's something that you need to know. And that is this. You can actually, if I go into interface G001 and I put in IP add of 172.16.0.1, so a /16 mask, okay, do a no shut. If I want to add that to OSPF in the real world, I can do the following. I can do router OSPF 1, I can do a network statement, and I can do 172.16.0.0, 255.255.0.0, area 0, do show IP prot, and look what it does. It automatically converts it to wildcard mask. Having said that, when you go to take the CCNA or any exam, you need to use wildcard mask. Real world, we can just put it in like normal and it converts it for us. Okay. On all the versions of iOS I've ever used, you could always put it in as a regular mask and it will convert it to wildcard mask for you under OSPF. Now, that's only true under OSPF, so don't be doing it with other things, but that's under OSPF. Questions about that? Questions about a wildcard mask? Because it's a little weird, but it's not anything too crazy.
No.
Notice here, if you had this mask, 255.255.255.192, your wildcard mask would be 0.0.0.63. So just subtract your mask, your subnet mask from 255.255.255.255, and you will have your wildcard mask. Now, this is a neat little thing because it gives you it actually is a new problem. You can just keep going as many times as you want. And so it gives you a chance to show, you know, decimal mask as is. And then wildcard mask is. So if your students need to practice, they can just keep doing this and do it as many times as they need. So I like these little things like this. They've got a lot of subnetted ones and some of that stuff in CCNA 1, which are kind of neat, which I like. Okay. Let me make sure I am recording. Yep, I am recording. Good. All right. So looking here at our particular setup, R1 is going to have 3 network statements on it. It's going to have the 10.114/30, 10.1.12/30, and 10.1.10.10/24. So here are my 3 network statements, all in area 0, because again, in this particular class, we're only dealing with area 0. And same with R3 would have 3, R2 would have 3 also, because we would not advertise this network right here that goes out to the internet in OSPF, not with a network statement. We're going to do it with a special statement called default information originate, which is going to generate a what's called a default route. But you'll notice that still be 3 statements here for R1, R2, and R3. The IP OSPF, this is another way to do it. Instead of using the network statements, we can do you can do it like this by actually placing the interface into an area. So you'll notice we didn't, now let me think, look at this. We go IP OSPF 10. That's our process ID, by the way, area 0. So that places that interface into that area. Why do you think it would be useful to use this method instead of a network statement? Can you think of any reason why it would be useful? What if you had to renumber your network anytime in the future? If you did this, it says whatever IP address is on this interface, put it into area 0. So you wouldn't have, if you had to renumber the interface with a different network, you would not have to change your OSPF network statements. It would just take that new network, place it in OSPF. So that's honestly about the only thing I've found would be a good reason to do it that way versus a network statement. But that could be a big reason if you down the road you were changing something for some for some crazy reason. The other thing I want you to notice that if you put this loopback into OSPF, it's going to send hello packets out that loopback, even though nothing's out there. Would be true too if this was a normal network that had hosts on it. So if this was an Ethernet that went out to host, and there's no other router out here, there is a thing you can do called a passive interface that you want to use on any network or link that you want to be advertised, but you do not want the router to maintain neighbor relationships on that particular link. So I can set loopbacks on R1, R3, and R2 as passive. You would not want to set the gig interports as passive though. As soon as you do that, it actually will allow them to receive hello packets, but they will not send them. So you will break the neighbor relationship between them. But if you have a loopback or you have an Ethernet connection that only hosts are out on that port, you need to make those passive. And you do that under OSPF's configuration itself. So you'll go under router OSPF 10. Remember, this is just a process ID. Now, I know they call it autonomous system number in the commands. It's not really an autonomous system number. It's just a process ID. But this passive interface loopback 0 would allow loopback 0 to no longer have hello packets going out that interface. You also can do, there's a way to make all interfaces passive and then turn off the interfaces you don't want to be passive. So depending on how the router is set up, that wouldn't make sense for these because only one interface needs to be passive. But if you had a router that had many interfaces that needed to be passive and only one that needed to not be, then it would make sense to just go in and make all passive and then make no passive on the one that needs to be actually on the network. Questions about that? Okay.
No question.
I don't know who's on the iPhone, but we're discussing OSPF point-to-point networks now. So we've had our broadcast networks. Remember, if it's a multi-access broadcast, we have to have the ability to do a DR, BDR election. On point-to-point, we don't have that, so we can actually just go in there and change it to a point-to-point network. So for some reason, by default, this link right here, even though it's Ethernet and it's point-to-point, it's seen as a broadcast network because it's Ethernet. So if this was truly a point-to-point Ethernet link, we could go in and reconfigure it instead of being a broadcast, where it's actually doing a designated router and a backup designated router election, even though it's not needed. We can change that link to a point-to-point link. So we can go to gig 000, and so IP OSPF network point-to-point. You have to do the same thing on the other side. Okay, so that has to match. And then there will be no BDR or DR election across that link. You can also do the same thing. You can actually simulate point-to-point links using our loopbacks by doing an IP OSPF network point-to-point on the loopbacks. So they appear to be loopbacks instead of they're point-to-point instead of multi-access. So notice if you do it, if you want to simulate a real LAN, loopback 0 is configured as point-to-point, and it will advertise the /24 instead of the /32. Otherwise, it actually advertises a /32 because it sees it as a loopback. So it knows there's nothing else there other than just that one IP address. So if you're really trying to simulate networks using a loopback, you need to tell it it's a point-to-point network. Okay. Bounce over here and let's see if this thing's up and running. See if my router has started running yet. Yep. All right. So let's go in here. Config T, no IP domain dash lookup first. Okay. So this is the iOS version that has no tag in it. Okay. Host R1. And I'm going to do interface LO0 IP add 1.1.1.1 255 0. All right, actually should be 255. Okay, and I'm gonna do a router OSPF 1 do show IP protocol, and we should see that our router ID is quad 1s. Now I'm gonna go into int gig 001. Actually, no, I'm not. Let me back up a second. Router OSPF1. I'm going to now set my router ID. Router-ID is 100.100.100.100. Okay. Nope, it did switch. Okay. So I guess they fixed that in this version of the iOS. So it did switch. Okay. So I learned something myself. So it will, if you put in the router ID, it will overwrite the loopback. That's good to know. That's why we have real gear, so we can test it and see. So used to, that didn't happen. You actually had to clear your IP OSPF processes in order for that to make the change, but I'm glad to see that's fixed. So now we've talked a little bit about point-to-point networks, obviously, just 2 devices on each one. We've got our broadcast networks, and on those broadcast networks, we need a DR and a BDR election in order to reduce the number of adjacencies that each router has to actually create. Remember, here again, if something's mentioned once, it's important. If you see it twice in the curriculum, it's very important. If you see it 3 times, it's on the CCNA. It's about a given, typically. So here is the all routers, all OSPF routers, multicast address of 224.0.0.5. And then the DR is 224.0.0.6. That's all designated routers. So the DR is the point where adjacencies are formed from all the other routers in the multi-access network. And then the LSAs are sent just to those 2. And then the DR is what sends out the LSAs to all other routers on the 224.0.0.5 multicast. And that keeps the other routers from having to flood the multi-access network with their link state advertisements. Does that make sense to everybody? So I don't know what has happened here, but here's the network. I talked about using the router IDs 333.222.111. That'll show you that the DR would be R3, or the whatever router set up for 3. The BDR will be 2, because it is the highest router ID becomes your DR, and then your next highest will be your BDR. So here we have, you can see router 2 is the BDR. Router 1 is the DR. Excuse me, router 1 is the druther. So state druther, which means it's neither the DR or the BDR. It could be if it needed to be, but it is not currently. You'll notice that designated router is 333, BDR is quad 2s. Router 2 is the BDR. Now you see this priority, there is a way actually on the interface to change the priority on a router, which will actually even override the router ID. So you can set a priority to a higher level than other routers, and you can influence the election without actually having to change the router ID. Higher is better. You also can set the priority to 0. So if you have a router that you know is just in no way, shape, or form able to perform the role of a DR or BDR, you can actually go into the interface that's connected to the multi-access network and give it a priority of 0, and it will not become a DR or BDR. And here we see R3, it is the DR. But by default, the priority on everything is 1. So here are different states we can see here. Full druther, that is a BDR or DR that has adjacent to a non-DR or BDR router. Full DR, it's fully adjacent with the indicated DR router. Full BDR, it's adjacent with a BDR. Two-way druther is they're exchanging hello packets, and it is not fully up and running yet. So the normal state of OSPF is full. You want to have a full and then some status, either druther, DR, or BDR in a multi-access network. You'll have a full state with no, there's no BDR, DDR. So And this is a two-way druther if they're actually sending information between those. Let's see if I can find here the election process. So it's really simple. They start up, they send out their information, they send out the hello packets. Inside the hello packets are the router IDs. As long as the priority on the interface has not been changed, highest will become your DR, second highest becomes your BDR. If you want to control it, you can actually change the priority. The priority is, let me check, I think it goes up to, I want to say 150. $255, 0 to 255. So 0 basically means don't participate. 255 means become the DR or BDR. By the way, if you put two of them at 255, it'd be the one with the highest router ID that would become the DR. So the router ID is used for the tie if you have the same ID. So DR BDR election is not preemptive. So if you do have you add another router with a higher router ID, you do have to basically either reboot all the routers or change or do that clear process like I talked about. So if the DR fails, the BDR becomes the DR, and then another router that was a druther will become the BDR. If the old DR comes back online, it will not be elected automatically. Okay. It will not automatically become the DR again. It will be a druther. So that's the process of it will not become another. It won't take its role back until you either reboot all the machines or clear the OSPF process on all the machines. So that's one thing you need to be aware. If you're doing updates for some reason and you wanted R3 to always be your DR, you would have to clear the processes on the others to get R3 back into the DR position. And then here's that OSPF priority command that you do on the interface. And if you set it to 255, that router in that interface, remember the reason it's interface is because it's got to be an interface in a multi-access network. That is what will become the DR. Put it at 0 and it will never become a DR or BDR. So pretty simple. Very simple. This is one thing that's a little weird, but it's changed recently. Remember, our metric in OSPF is cost, which is a direct factor of the speed of the link. Used to be our reference bandwidth is 10 to the 8th divided by the interface bandwidth in bits per second. You can change the auto cost reference bandwidth if you want. The reason you may want to do that is because with the default Cisco costs, a 10 gig and a 1 gig interface have the same OSPF cost, but you would not want that. I mean, it would make no sense for those. So you can actually change it. You can put it auto cost reference bandwidth 10,000, and then at that point, your 1 gig would have a cost of 10 and your 10 gig would have a cost of 1. You got to be aware now too, though, we even change it more in our data centers because we've got 100 gig links, we've got 40 gig links, we've got 400 gig links now. So if you're running OSPF in a really high speed environment, you may have to change that default cost. It's called the reference bandwidth cost or the reference bandwidth. At the very least, we want to change it if we have 10 gigabit links, so that we'll have a correct use of our different interfaces. All right. That's the most common we'll use is auto cost reference bandwidth 10,000 because most of our links don't go beyond 10 gigs in our basic networks. Now in the data centers, things get nuts. We get much faster in data centers. All right. And that is, you also have the ability, but you need to be very careful with this. And they are extremely cautious. And that is, you can set the actual cost on an interface. You would only ever do this if you were really trying to manually, for some reason, shape the traffic in your network. Okay, so you really wanted to make sure that traffic went a specific way, or for some reason you really wanted one link used more than another link. But it's not recommended. You also need to change it. If change it on one side, make sure you change it on the other side. Otherwise, you get in some weird trouble with that. Our hello packet interval by default is every 10 seconds. So every 10 seconds on multi-access and point-to-point networks. You stop those packets with that passive interface command. The dead interval is 4 times the hello, which is 40 seconds. On non-broadcast multi-access networks, it's 30 and 120. Again, that's beyond the scope of this, but that would be down frame relay and other things that we deal with when we get into CCMP uses of OSPF. You can change those. If you do a show IP OSPF interface, you'll see your hello and dead times. And you can actually change those with the IP OSPF hello interval, put it into seconds, and your dead interval should be 4 times whatever your hello interval is. And I love this. I show you how to do it, and then they say should only be done in rare situations. But we do teach how to do it in case you get out in the real world and for some reason you need to do it on a link. So now this is very important. This is called default route or default static route propagation. So you'll notice here we've got an OSPF area connected to the internet. And we want all the routers inside to have a way to get to the internet without having to put a static default route on each one of these routers here, R1, R3. We know that R2 is our border between our internal OSPF network and the internet. So we're going to put, since this is our ISP, we're going to put a static route on R2 that goes out to the internet. Now we're simulating that with loopback 1 here in our reference topology. But just imagine that was a real link going to a real ISP. So what we would do is we'd put a static route on R2 with the quad 0, just like normal, and do our next hop IP address and exit interface. I'd probably do a fully qualified route, especially if it happened to be Ethernet. But then inside of OSPF on R2, we just put the simple command default information originate. I kind of call this a magic dust command. But what it causes R2 to do is R2 sends out then a default route to R1 and R3. And in fact, if there were 100 routers below these two, R1 would send a default route to those below it, and R3 would send default routes below it, all pointing back up to R2. So when you do this, you can look into, here's R2's static route. But in R1, you'll see what's called an OE2 star quad 0/0, which is, this is an external OSPF route, candidate default, and this was propagated down to R1. You did not put any static route on R1. You did not do anything. That all came from R2 when you put in this static default route and enable default information originate on R2. Now this command, default information originate, only goes on the one router that is the border between your OSPF network and your ISP. Wherever your default route out to the ISP is, that's the only place you put default information originate. And then every router inside in its route table will have this route or a route. It's not this exact route, but it'll be a default route, OE2, that will eventually get up to R2 to get out of the network. You have a lab on that and packet tracer to do. It's really very simple, but where people make the mistake is they put default information originate on all the routers when it should only ever be on the one OSPF router that is connected to the ISP and it has the static default route on it. Like I said, the cool thing is that would be propagated on down. So if there's a router below R1, it would also get a default route that pointed back up to R1 that then pointed to R2, which is really neat. Saves you a lot of trouble in an OSPF network. So how do we verify OSPF? It's really simple. I've shown you a couple of the commands. Show IP interface brief, show IP route, show IP OSPF neighbor. Okay. So if I go over here right now and stick another router in here. And let's see, let's connect it. And I think I did. 02. Let's go ahead and let this thing boot real quickly. I'll just do a real quick OSPF network here. We got 172.16.0.0 on this side, 192.168.12.0 on the other side. I always use those addresses because it's just easier for me to know IP domain. Okay, host R2 at G00. Poop, can't remember which one I connected. I think I did 0. Yep, okay, that's it. IP add 172.16.0.2. I'll do this. I'm doing something a little different. Let's do 0.0.0. Let's actually do the other way. Okay. IP OSPF. I do 1 area 0. Put in area 0. Okay. So now do show IP OSPF neighbors. We don't have any yet. Nope, that's because I hadn't turned on OSPF over here yet. So let's go back over here. Okay. Yeah, I did have it in there. So should do show IP OS neighbor. Do 172.16.2. Well, there we go. Huh. It's not wanting to use that, not wanting to use that command. Okay. Yeah. Well, that works. Put our network statement in. Let me do it correctly. I won't cheat. Seven two 16.0.0. That's correct. Oh, that's right. So let's do. All right, y'all. I'm confused. One 172.0.0. Here's 0. 12.0. All right, that. Y'all seen anything I'm not seeing that I messed up here? Other than We should have had a BDR election here. Show IP, OSPF interfaces. Gig 00 is that scenario 0. 172.16.02 type broadcast. It's waiting. No designated router yet on this network. It's not forming a neighbor relationship for some reason. What we got here, chat was.
Kelly,
Nope. Yeah, I hadn't changed any of the
Kelly,
timers or anything.
Kelly, this is Clay.
Hey, Clay.
I think it might be easier if all the devices were connected to the switch.
Yeah, but see, these two should be connected right here across that. So we should be getting, unless there's nothing in here. No VLANs. I mean, it should just be a simple, literally a simple OSPF setup. Let me see something here. Let me say show. I bet I know what it is. I bet I used a /24 on. Nope, a /16. So I can get G000. It's also there it is. Dadgummit. There it is. 172.16.0.2 255.255.0. There it goes. Dead nabbit. Always something simple that bites you in the rear end. See, I had a /24 and a /16 on the other side.
Okay.
So that's what it was. Yep, there she goes. Show IP OSPF neighbors. There's our neighbor. Okay. Show IP route. We'll see we've got a route from R1 for 192.168. Now what I wanted to show you is this. I want to put I'm actually do a loop back here, another loop back. So let's do config T int L01 IP add 204.211.19.18. I knew it was something simple I was doing wrong. All right, and then we're going to do a no shut. And I'm going to do exit here, and I'm going to do an IP route quad 0. And next hop is 204.211.19.18. All right, let's do LO1 then. We can do LO1. All right. And then we go into router. Now notice, first off, let's go down here to R2. Notice there's no gateway of last resort on this router right now. So there's no way to get out to the internet. So we're simulating the internet at this loopback 1. We'll go into router OSPF 1. We'll put in default information. Oops. Originate. And then notice what happens over here. It may take it a few minutes, but there it is. There is the route that gets sent by R1. And here's the cool thing. Like I said before, if I go in here and I add another router downstream, so let's just add another router just very quickly. It won't take but a second here. If I type it in right, it won't take but a second. So gig 001. So let's do config T int G001. God, I cannot type, y'all. Gee, I used to be so good at typing. I'm gonna do IP add, and let's make up another address. 131.107.0.1 255.255.0.0. So /16 router OSPF 1 network. Put this one in there. So we got 131.107.0.0. Zero. We're gonna go over here and let's do a no shut. Int B001 shut. Okay. Let's go over here. This router. Oh, let's go. 3. Int G000 no shut. Comes up. IP add. Make sure I use the right mask. Router OSPF1 network. So we'll get a neighbor relationship here in just a second with R2. Oops. Did I put an IP address on it? Nope. Yeah, I did. Okay. So we got our neighbor relationship. Now notice, I'm gonna drop out of here. I'm gonna do it first. Show IP OSPF neighbor, and you should see your neighbor over here. But notice it's a full DR, even though it's point-to-point link, because we haven't changed it. Watch this. Show IP route. Look at that. It's got this OE2 that now points over to router 2. And then router 2 has an OE2 that points over to router 1. And so that one default information originate command right here will propagate all the way down. So if you had another 30 routers in here, it would keep going down in each one of them. So as long as you have that one default information originate on the router that's your border, it'll go to all of them. That makes sense? Okay. You'll notice I use this command, show IP protocols, show IP OSPF interface, show IP OSPF. All of these were used. This, I had to look to see if a neighbor relationship was established first. When it wasn't, I knew immediately to troubleshoot that. Show IP protocols tells me what networks I'm routing for, what my router ID is, what interfaces are passive, which ones are not. And show IP OSPF will show you all your different information about the process. It will also show you when the LSAs have been sent and what particular area you are part of. And last but not least, you can also do verify OSPF settings. You'll notice again down here, if I look at this router's, if I do a show IP OSPF int G00, G000, you'll see this says it's a broadcast type because this is Ethernet. But if I wanted to, I could actually change this to point right here because that is a point-to-point Ethernet link. This, however, is a multi-access link here because we got the switch in the middle. So we would not want to change it on that one. And folks, that's pretty much OSPF in a nutshell. Not a whole lot to it other than that, as far as for this level. Now we'll go to the next level, whole different ballgame. We get into multi-OSPF, we get into all kind of different areas that we can do that are available. So folks, I want to remind you again, well, first off, any questions on OSPF? Be working on the labs, getting those done and turned in for me. I want to remind you again that we will not have a class meeting next Monday, but we will be back the following Monday. So Monday, the 6th of March, we will be back. Next week, we will not have a class meeting. All right, I'm going to stop the recording.